So when you did the wavy for the acceleration, it's not a wavy, it's a straight line.
Yes, yeah. It is now self-consistent, so that this is the slope of that is the slope of this. And the last bit is, when doing it, it needs to be what I'll refer to as differentiable. In other words, it needs to be no sharp points. It needs to be continuous, so no breaks. I'm not gonna have a velocity that goes like this and then suddenly like that. And it needs to be a function, so no vertical lines. Mr. Young sticker there. So no sharp points, no vertical lines, continuous. All right, questions before we actually do a test level problem?
So if the velocity is always constant, the acceleration is always going to be constant?
If velocity is constant, acceleration would always be zero.
Well, and I mean...
If this is a line,
yeah.
this will be constant, yes. It turns out, present this without any justification other than an example right there. Parabolas is something x squared. Parabola is going to have an x squared plus x plus so on. If second order polynomial, when I do the slopes, it's going to be something to the x. And if I did the slope of that, it's going to be something that'd be x to the first, x to the 0, which is just 1. So that'll be constant, that'll be a line, that'll be a parabola. If this is x cubed, this would be x squared, that would be x to the first, and then the next one would be constant. It always, if you're dealing with polynomials, each slope would be 1 power less.
So, because derivatives, when you have a derivative, you put the power in front of it. That doesn't, like in physics, does it not?
Oh, it matters, just not, in 151 it's not a calculus-based course, and so we will touch a little bit on that when we get into waves. And we'll talk about it conceptually, and then I'll give the specifics of, oh, that just pops out here. And also, there was, I've done in the past where I've given a graph, and I said if it's a position graph, where is its speed number slowing down? And I gave the equation for, if you do calculus, you could use calculus if you wanted to, or you could just do it from the graph itself. All right, a test level problem. All I really care about is the horizontal piece of this. Now, on the test, I would define each one of these very specifically. I'm going to sort of hand wave through some of this. It starts out at time A, and it's going up the ramp. It's going to go up, it's going to turn around at point B, slide down along this, hit the horizontal bit, and then move up here, slide back, and it's going to end at J. J is the point where it's about to turn around again. In order for it to turn around, there has to be some loss. There has to be an additional force involved. So over here, there's friction over here. And I'm going to represent that by mu sub k is not 0. This is just saying that there is friction. Use of K is the coefficient of kinetic friction. It deals with basically the nature of the rubbing while the sliding is going on. And then at these three locations, use of K equals 0. In other words, those are all frictionless. E and I time when box is first / last completely on horizontal section. So at time E, the box is now completely on down here. At F and H, time when box is last / first on horizontal section. And I laid it out more explicitly again on the test. In other words, at E, I, H, and F, the box is completely on this horizontal spot. It has not quite transitioned. We assume that all the transitions are smooth, that even though I've drawn it with a sharp point there, that it really is not sharp. I'm going to present this a little bit differently, just to give you a different idea of how to do it. So I've got A, B, B, C, 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 D, D, E, F, G, H, J. All right, those are all the different time intervals we need to address. Should have brought up the graph paper side of this. Oh well. Need one more. This one. This will be position, displacement, velocity, and acceleration. All right. Oh, I do need to define two other things. Originally, I didn't define the positive direction and let students define it. Unfortunately, it's a lot harder to grade when answers are completely opposed to each other, when people pick different directions, so I started assigning the positive direction. I need to also establish 0, and so let's make this point right here the origin. All right, so questions on what's happening in the problem before we actually look at the answer?
Just like about the so we're filling in that entire graph or that entire chart is going to be the answer to such problem.
Yes. What you're going to find on the test is that I set up the problem and I give you 4 different ways to present it. You pick one of them. Please only pick one. Or if you pick more than one, please be consistent in your answers. So the first way you did it was using the brackets and so forth. This way, I'm just going to put a plus minus of 0 in each blank. This has the advantage of it's a lot harder to have one moment in time be positive, negative, and 0 at the same time. unlike the parenthesis bracket method. All right, so let's start out, where's position 0?
Okay.
What'd you say? Try that one again. You get ahead of your time. Position.
There is no gonna, there's not gonna be a position that's 0 because it's above the origin.
All right, we're just a little clear about horizontal pieces of it. At what times is it at the origin? I heard I, yes, one of them, and yeah, E and I. So it's 0 here. Oh, we can. Yeah, that just pops, right? E and I. There we go. Once you establish zeros, I know everything in between, because it can only go from positive to negative by passing through 0. I know if I can identify one thing, if I have my zeros correctly, if I have them correct, then if I can identify one point in between, I know all the points in between. What about before E? Is my position positive, negative, or 0?
Negative.
Negative.
What about between times E and I?
Positive.
And after it passes time I? I just want to point out, even though C, D, E, I, F, and G are written below, this object is not sliding along below it, it's just, I needed to somehow signify, at time C it's here, at time D and J it's there, E and I, A and C, H and F, G's by itself, that's a turnaround point. All right, displacement.
Zero at A and C.
What else in between?
Negative. Negative.
Because it starts out going to the left. And then after it passes time C,
Positive.
all right. Where's velocity equal to 0?
Oh, we forgot the J component.
Oh, thank you.
F, D, and G, and J.
Yep. So B, G, and J.
B, G. So, like the turning points
Yes.
and the stopping point.
In order to turn around, it's not traveling in a circle, so it has to stop in order to turn around at G, B, and J. Right? What about before B?
Negative.
It is indeed, it's going in the negative direction. What about between B and G?
Positive.
Because generally to the right.
Yeah, it's negative.
Now, notice that in each of these cases, at 0, it did pass from negative to positive. It's not always going to do that, but it does in these cases. It's just that if it is going to go from negative to positive, it has to go through 0. All right, questions up to here before we tackle the tough one? All right, let's tackle the tough one. Do we know where acceleration would be 0?
There is no.
Yes, there is someplace.
Never mind.
Would it be at the starting point? No.
It's already moving at the starting point.
At the changing points.
F and H.
Say it F and H. Why is it 0 at F and H?
This is time where the velocities last first on the horizontal section.
It is on the horizontal section. All right, so let's tackle it slightly differently here. As it's going from A to B, speeding up or slowing down? My velocity is negative, so what does that tell you about the acceleration?
Wait.
Oh, so it's
Slowing down, dude.
Oh,
there.
All right, so it's positive. What about a B? Hint, it's not 0.
It's
Zero.
negative.
So you're saying it can go from positive to negative without going through 0?
Positive.
It's positive. Matter of fact, it's going to, after B, it's going to be speeding up until it gets to what point?
G.
It's going to get faster as it goes up that other slope?
No.
Whoa!
H.
Why is it going to go faster on that horizontal piece?
Oh, wait, no, no, or E.
It's faster until it gets to point I.
E if it's going in that direction.
Yeah.
Yeah, it's going to go faster until it gets to point E. So it's still, because my velocity is positive, it will be positive. Oh, and then we get to E, so let's undo that one and figure out what's happening there. And E, it's on that horizontal section.
So it's
Zero.
0.
It will be 0 there because there's nothing that's making it go faster. It's not going downhill or uphill, so the speed won't, there's nothing to cause the speed to change. There's no friction to slow it down. And so it is 0 here to F, and then it gets to the ramp over on this side. It will slow down as it goes up the ramp, I hope. If it speeds up going up the ramp, one, if we could actually create that, we'll be millionaires. Actually, millionaires, probably putting it mildly. And two, we would be breaking laws of physics. So as it goes up the ramp, it's slowing down.
And at G, it is negative as well.
And what about from G to H?
Negative.
What about from H to I?
0.
Zero.
0. Again, you can't go from negative to positive without going through 0, but it is 0. And then when it gets to the left-hand side, after I and up to J,
Positive.
please note. These are, I was asking for the instantaneous value. This one is the overall value. What I meant by the default yesterday. If I ask for average velocity, which I don't do on this problem, but if I ask for average velocity, what would it look like?
You said average velocity?
Yeah. Which, average velocity is going to look like one of these. What's the formula for average velocity?
Change in X over change in time.
So overall displacement over time. Well, time's always going to be positive. Change time will always be positive. I hope. Unless my time machine gets to work.
The velocity?
It won't look like the instantaneous velocity.
Still gonna look like,
Overall.
The displacement, overall displacement, yeah. These are my only vectors right here. So the vectors have to be, since they're on each opposite sides of the equal sign, the directions have to be the same. So my average velocity would look like this. which is one of the reasons I don't ask for that, because it would just be identical. Notice none of these are the same. Please don't put them all the same. Ibrahim.
Where would, because, so we've mentioned position, displacement, or overall displacement, velocity and acceleration. Where would speed come into this?
Speed is the instantaneous speed is the magnitude of instantaneous velocity. So if I ask for instantaneous speed, you basically take this and anything that's negative, make positive. The speed doesn't care which direction you're going in, it's positive number. Average speed would be distance over time, and distance is always positive. Yeah, as soon as you start moving after time A. So at A, your average speed would be 0 because you haven't gone any, well, no time has passed either. No, so speed would be positive the entire trip. It's never 0 because you've gone some distance.
Okay.
Yeah, speed would be a boring thing to ask on this. Oh, wait, that's, yeah, average speed would be positive the entire time.
Just curious.
Actually, I think you could easily make the argument that at time A, that's when the problem starts. You can't have average speed. It can't be defined because no time has passed at time A. Instantaneous speed, yes, average speed. I think I'm shooting off on my own tangent here. I'm gonna stop. Questions?
The average, the average we just did, will it always just be the velocity row? Like if we
Average
do-
velocity will always be the displacement row. Because it's displacement divided by time.